Within the next minutes, you will be introduced to waste valorization solutions considered in iCAREPLAST project by means of the use of oxygen transport membrane technology with CO2 capture. The ITQ Reference Research Center in the field of catalysis, the Energy Conversion and Storage Group counts with almost 17 years of experience in gas separation membranes for applications focused on industrial processes sustainability. Regarding chemical sustainability, it is worth to mention that the most of the processes conducted in the chemical industry generate a big amount of non-profitable side streams. These streams, normally consisting of hazardous or polluting compounds, require from the addressing of actions. But what to do with these byproducts? Send them to landfill, dump them to the atmosphere, or to the environment? Of course, the answer is no. What is typically done is to conduct a valorization of these streams by, for example, combusting them for exploiting their energy and use the produced heat and power in the process, thus increasing its efficiency. This is known as cogeneration. However, combustion of waste streams leads to another problem: the generation and emission of pollutants such as CO2, NOx 1, NOx 2, and others, which subsequently will affect the environment. A solution for this problem is to conduct the combustion with pure O2, in the way that only CO2 and water is generated. Then by condensation, water is removed and CO2 can be easily captured, not producing any emission. This process is called oxycombustion. But that leads us to another question: how can we produce the O2 required? Currently, the cryogenic distillation of air is the predominant process. Nevertheless, it requires from large installations and high energy costs and the high-costing bulk supply for its use in medium and small applications. Pressure swing adsorption is another technology for producing O2. However, the obtained oxygen purity is below 90%, and the fact that it is a discontinuous process make PSA as not suitable for CO2 capture applications. O2 production by means of a ceramic membranes is a very appealing option for producing nearly 100% pure O2 streams and has the benefits of thermal integration within processes presenting waste heat streams. In addition, this technology can be integrated in medium and small-scale applications. But how do they work? Membrane materials consist of ceramics with oxygen defects. That is, in the material structure, there are empty places where an oxygen anion should be, but it is not. This is the basis for, at temperatures above 600 degrees Celsius, oxygen anions diffusion from one side to another, thus producing a pure O2 stream. At lab scale, OTM typically are tested at discs of Ca. 15 mm of diameter, producing a few milliliters per minute of oxygen. Nevertheless, it can be conducted as an upscaling via surface increase and membrane stacking, leading to OTM modules able to produce up to 1 ton per day of pure oxygen. Therefore, the oxygen production can be tailored for each demand by stacking as many membranes as needed and also by considering several modules. Hence, this solution can be integrated in medium and small-scale applications. The requirements of high temperatures for being operated makes OTM technology to be a very appealing option for being integrated in processes where waste heat streams can be exploited. As this example in the slide, where a hot flue gas is used for sweeping and collecting the produced O2 for the combustion. Regarding iCAREPLAST chemical recycling process, it has produced a generation of gas side streams consisting of a complex mixture of hydrocarbons and hydrogen. In order to exploit this stream, an oxycombustion coupled with a CO2 capture is considered. Therefore, iCAREPLAST proposal considers the integration of OTM technology for the conduction of an in situ O2 supply, permitting the oxycombustion of the generated side streams, the production of heat, and the avoidance of any emission. As said, for the iCAREPLAST project, it is considered an oxycombustion consisting of an in-situ O2 supply, so the combustion chamber is inside the OTM module. Therefore, the combustion heat is also used for the module heating needed for its operation. And how will this be developed in the frame of iCAREPLAST? First, by defining membrane and catalysts materials, then by upscaling the concept, and finally by demonstrating it in a pilot plant. Therefore, the demonstration of this technology will enable the implementation of a plastic chemical recycling closed loop in a sustainable and efficient way and with zero emissions. There is urgent need to develop groundbreaking technologies to address circular after-use pathways for plastic waste with zero emissions. Oxycombustion with OTM-based systems considered by iCAREPLAST can contribute to these objectives.